Hello friends, myself R.D. Mahajan presenting my video on directional derivative. And to explain this concept, let us see the figure. Uh, let phi of xyz be any scalar point function in this scalar field, and we have 2 points, point P and point Q, at two adjacent points in that field. Then if we join that point P with origin O, we get its position vector as r bar, therefore vector OP as r bar. If we join that point Q with the origin, we have another vector OQ as r bar plus delta r bar, and then that vector PQ, as per the vector algebra, it is vector OQ minus vector OP. Vector OQ is r bar plus delta r bar minus r bar. R bar get cancelled. We get that vector PQ as delta r bar, and the length of that vector PQ be suppose delta s. And if we take the limit of delta phi by delta s as point Q tends to P, we get delta s tends to 0, and if this limit exists, that value is d phi by ds. That d phi by ds is called as a directional derivative of that function phi at point P in the direction of vector PQ. Therefore, this derivative obtained in the direction of some vector is called as directional derivative. And the formula to obtain that directional derivative is grad phi delta phi dot a cap, a unit vector along that vector A, and the value of that unit vector is that vector divided by its magnitude, and therefore by this formula we can determine the directional derivative of any scalar point function. Therefore, whenever we require to obtain directional derivative, we require two things: given scalar point function phi, obtain its gradient, and second, vector a bar, along which we require to find directional derivative. If we have these two quantities, we can determine that directional derivative very easily. Therefore, let us see first problem. Find the directional derivative of function phi of xyz. That function is xy square plus yz cube at the point 1, -1, 2 in the direction of vector 2i plus j plus 3k. And therefore, to find directional derivative is given by grad phi dot a cap. This is nothing but grad phi dot unit vector a cap is given by that vector divided by its magnitude. Therefore, by this formula we can obtain the directional derivative, where that vector a bar is given vector, and it is 2i plus j plus 3k. We call this equation 2. Another quantity which we require, that is grad phi. Grad phi is given by, as per definition, that operator there is I dou by dou x plus j dou by dou y plus k dou by dou z, which way to operate on phi, and then operating that operator we get dou phi by dou x into I differentiation of that phi with respect to x into I plus dou phi by dou y into j and plus differentiation of that phi with respect to z into k, and therefore gradient of that function phi is equals to differentiating this phi with respect to x. Symbolically I can write it as dou by dou x of xy square plus yz cube into I. Then differentiating the same with respect to y, it is dou by dou y of that function xy square plus yz cube into j and plus differentiating it with respect to z, it is xy square plus yz cube into k, and then performing that differentiation, partial differentiation. When we differentiate with respect to x, we have to consider y and z as constant, and therefore we have derivative of the first term with respect to x is y square, and derivative of the second term with respect to x is 0 as no term of x is there, into I plus differentiating the second term, that term with respect to y, its derivative with respect to y is 2xy, and with respect to y its derivative is z cube into j. Differentiating the same term with respect to z, its derivative is 0 as no term of z is there, and derivative of this term is 3z square y into k. Then we find its value at the point 1 minus 1 2. Therefore grad phi at point 1 minus 1 2 is equals to x is 1, y is minus 1 and z is 2. Therefore minus 1 square we get 1 into I, then plus 2xy, 2, x is 1, y is minus 1, plus z cube, 2 cube is 8 into j plus 3 z square, 2 square is 4, and into y is minus 1 into k, and then simplifying it we get that vector as 1 into I is I, this one is minus 2 plus 8, 2 into 1 2 into minus 1 minus 2 plus 8 we get 6j, and 4 3 is 12 into minus 1 we get minus 12 k as equation number 3. That directional derivative is del phi. The value of del phi is vector I plus 6j minus 12k, a dot product with that vector a bar. The value of vector a is 2I plus j plus 3k, and divided by its magnitude. Magnitude is given by root of x square plus y square plus z square. X square means 2 square 4, y square 1 square 1, and 3 square it is 9. And then it is equals to dot product of two vectors is a1 b1 plus a2 b2 plus a3 b3. Therefore 1 into 2 we get 2, 6 into 1 we get 6, and minus 12 threes are 36 divided by root of 10 plus 4, it is the root of 14, and therefore it is 6 minus 36 minus 30 plus 2, we get minus 28 divided by root of 14. Units. Therefore, the value of directional derivative along this vector 2i plus j plus 3k is minus 28 divided by square root of 14 units. One more example I will discuss in my next video. Therefore, if you are watching my videos, please like and share it, as well as subscribe to my channel to get latest updates or new videos. Thank you. Thank you very much.